In 100 years, humans could be waking up on Mars or walking through floating cities above Saturn's moons. Science fiction? Not anymore. With technology accelerating, this future might be closer than you think. But how will we get there? The future of humanity could be among the stars. But where exactly will we live? And how will we make it happen? Earth has been home to humanity for over 200,000 years, but it may not always be our only home. The challenges we face today, overpopulation, environmental degradation, dwindling resources, and the looming threat of climate change, are forcing us to look beyond our planet. Earth, while beautiful and vibrant, has finite resources. And as our global population continues to grow, we need to find new frontiers for humanity's survival. Space is the ultimate frontier, offering vast, untapped resources and potential new homes. Colonizing space could ensure the long-term survival of our species. While there are immense challenges in making this a reality, humanity has always thrived when facing the impossible. The vision of living beyond Earth isn't just about survival, it's about exploring, evolving, and securing our place in the universe. Mars has long been seen as the most realistic destination for humanity's first off-world colony. It's the closest planet that has a somewhat familiar environment. A day on Mars is only 40 minutes longer than a day on Earth, and it has polar ice caps, seasons, and weather systems. However, it's still incredibly hostile. Its thin atmosphere is mostly carbon dioxide. Mars presents the best opportunity for creating a self-sustaining colony. Advances in technology, like those being developed by SpaceX and NASA, have made Mars colonization more feasible than ever. SpaceX's Starship is designed to transport large numbers of people and equipment to Mars. Elon Musk envisions cities of 1 million people living on Mars within the next century, and early efforts will focus on building sustainable habitats. Due to the high radiation levels on Mars, living on the surface may be dangerous without protection. Early settlers will likely build habitats underground or within natural caves to shield themselves from cosmic rays. These colonies would be pressurized and temperature controlled, with life support systems providing oxygen and water recycled from the environment. Some scientists believe that over time, it might be possible to terraform Mars by releasing greenhouse gases into the atmosphere to warm the planet. This process could take hundreds or thousands of years, but could eventually allow humans to walk on Mars without a spacesuit. Mars colonies would need to be self-sustaining to thrive. Hydroponic farms could grow crops indoors, utilizing artificial sunlight. Mining operations could extract water from ice reserves, while solar energy and nuclear reactors could power the colonies. Over time, Mars could evolve into a place where humans not only survive, but flourish. While Mars may be the first planet we colonize, many futurists believe that massive space stations could become homes for humans in the next 100 years. These would be rotating habitats, designed to simulate Earth-like gravity through centrifugal force. Concepts like the O'Neill cylinder, a vast rotating space habitat, could house tens of thousands of people. Space stations can be built anywhere in space, around the Earth, Moon, or even in orbit around asteroids. This would allow humans to live and work closer to valuable resources, like asteroid mining operations or scientific research outposts. One of the biggest challenges of space habitation is the lack of gravity, which causes muscle atrophy and bone loss over time. A rotating space station can create artificial gravity, helping to mitigate these health risks. These stations could also be self-sustaining, recycling water and air, and growing food in artificial environments. Orbiting space stations could support agricultural zones, utilizing vertical farming techniques and hydroponics to grow crops. This would make space stations less reliant on Earth's resources and help support larger populations. Space stations near the asteroid belt could harvest metals like iron, nickel, and platinum, essential for both building and energy production. These resources could fuel further exploration and colonization efforts, planets, making the space economy self-sufficient. As we venture further into the solar system, the moons of Jupiter and Saturn may become the next great destination for human colonies. Some of these moons have characteristics that could support life, or at least human habitats. Europa, one of Jupiter's moons, is covered in ice, but beneath its frozen surface is a vast ocean that may contain more water than all of Earth's oceans combined. If there is water, there may be life, and Europa could one day become a destination for scientific research stations, similar to our Antarctic bases today. These research stations could be the first step toward a permanent human presence on Europa. Titan, Saturn's largest moon, is another promising candidate. Titan has lakes and rivers, not of water, but liquid methane. It also has a thick atmosphere, which could provide protection from space radiation. Some scientists have suggested that floating cities could be built in Titan's upper atmosphere, where temperatures and pressure are more Earth-like. These cities could extract methane from Titan's surface to use as energy, making the colony largely self-sustaining. Living on these distant moons would require significant advancements in energy production, life support systems, and transport technology. However, the potential for resource extraction, like methane on Titan or water on Europa, makes these moons incredibly valuable in the long-term plan for space colonization. While the vision of space colonization is inspiring, the challenges are immense. The cost of sending humans and equipment into space is still prohibitively high, though companies like SpaceX and Blue Origin are working to reduce it with reusable rockets. Even with advancements in transportation, the journey to Mars alone takes over 6 months, and trips to Jupiter or Saturn could take years. Then there are the health risks. Long-term exposure to cosmic radiation can cause cancer and other illnesses. Developing radiation shielding and effective health measures will be essential for protecting space settlers. Another issue is the psychological toll of living in isolation, far from Earth. The first space colonists will have to contend with isolation, confinement, and limited communication with loved ones back home. Advances in virtual reality and AI may help create more immersive environments for mental well-being. The next century could be transformative for humanity, with space colonies becoming a reality. Mars colonies may lead the way, but rotating space stations, lunar bases, and even habitats on the moons of Jupiter and Saturn could follow. However, the future of space colonization will depend not only on technology, but also on international cooperation. Colonizing space will require collaboration between governments, private companies, and scientific communities across the world. But the momentum is building. NASA, SpaceX, and international space agencies are investing heavily in space technology, and the private sector is increasingly involved in the space race. As technology advances, the barriers to space colonization will shrink, and our presence in the solar system will expand. In 100 years, humanity may not be confined to Earth. We could live in cities on Mars, orbiting space stations, or on distant moons like Europa or Titan. Our journey beyond Earth will be difficult, but it's within our reach. The future of humanity lies in the stars, and the next century will likely be defined by our leap into the final frontier. Where will humans live in 100 years? Perhaps the better question is, where won't we live?